Hey you folks, Quill18 here, and about 4 months ago I ended the last TileMap tutorial with I'll be right back with the next segment on data structures, and well, apparently I lied, or got busy or something, and I apologize for taking so long to get there, but we're going to look at that today. So what we're going to do is cover the sort of data structures you want to maintain your tile map information. And this is completely distinct from the ability to display a tile map in some way on the screen, which is what we've worked on to this date. And what's going to be interesting about this is, or what's going to be useful about this, is that you can change how you display the tile map on the screen without needing to completely redo your entire data structures. They're going to be distinct from one another. Also, they allow different types of optimization and saving and all kinds of great stuff. That is awesome. So obviously, we are going to continue to visualize our tile map using the stuff that we've developed to date. But when Unity 4.3 comes out, and Unity will have built-in 2D graphic support, you might want to go and use that if what you're trying to do is a pure sort of 2D map like this, you know, no sort of 3D height information or anything like that. If you're always going to be doing top-downy kind of stuff, you might end up using a 2D engine, and there's nothing wrong with that. That'll work perfectly fine. Alternatively, maybe you are going to want to create a kind of a dungeon crawler, Diablo-esque kind of game, in which case you might want to display things in sort of three-quarter view, and instead of a 2D-ish kind of display, you might want to use actual 3D objects. Like for wall tiles, you might want to actually just instantiate a wall object, you know, a cube that's going to represent your wall in place of that, not use this sort of procedural 2D tile map in any way whatsoever, and that's totally valid. And you can use the same data structure that we're about to develop together to do that. And what we're going to do as an example, instead of these Civ style maps, I'm actually going to swap to kind of dungeon generation, because I actually get a lot of questions about that. Part of the problem is that terrain generation is not something you can kind of answer in a global kind of sense. I mean, Dungeon 1, not as much either, but there'd be more talk about maybe per-line maps, different fractal kinds of generation, weatherware. Like, it's such a big open-ended question for really making good sort of continent or terrain type, and like what scale of map are you doing? Do you just want one valley? Do you want your whole world? So I'm going to simplify the equation a little bit by talking about dungeons instead. So what I've gone is I've created a new tile set. This is going to be for my dungeon here. The black is going to be my tile ID 0, which represents just unknown stuff at this point, which almost doesn't make sense. Like, how can a tile be kind of unknown when we generate a map? The thing is, ultimately, you're going to want to do two sets of tile map data. One is going to be the actual map data, and the other one might be what the player knows, because a lot of these dungeons rely on exploration. So the player's map will start off all black, and then based on where the player is, you're going to use some sort of vision code to determine what tiles can the player see, and then for all tiles that the player can see, you're going to update the player's version of the map with the real version of the map, which is going to have this. This gray area is going to be generic floor tiles. This red with the W is going to be a wall tile, and this blue with an S is going to be just various stone tile. It's just what I've decided to use. Obviously, I mean, first of all, you can create, you know, dozens and dozens and dozens of different tile types, and obviously you'd want some kind of art, but for maximum clarity for this sort of debugging, I thought this would be an excellent idea, so we should be able to clearly see what's going on. So I'm going to create sort of NetHack style dungeons, very old school roguelike kind of dungeons where you have square rooms connected by corridors. The rooms will have the gray stone floor. They will all be enclosed by walls, and then anything that's not sort of floor or walls will be this kind of stony kind of stuff. And that's, you know, very simple, very basic approach, but it actually is going to present a lot of techniques that you're going to use in general. So first thing we're going to do, and I apologize, I haven't worked with the TileMap system in a while, so there might be a little bit of relearning for me to do. I'm going to select the actual tile map we have there. I'm going to just replace our texture atlas. Instead of using the Civ one, I'm going to use the Dungeon one. We can hit regenerate, and we'll definitely see that, yeah, all right, we're using those tile types. Excellent. Obviously, it still, you know, kind of looks like nothing, but all right, our graphics are in there, which are great. Then I'm going to flip into our code, and I had to refresh myself on how the code worked, and I was reminded of how many things in here actually don't work the way that they're supposed to. Like, we still have the random generation technique, which frankly, this whole thing is going to get torn out entirely. It's still hard-coded to rely on the fact that we have 4 actual tiles in our texture map, which is obviously a big mistake. Also, the number of tiles per rows, I mean, they should really kind of get stored as a global, and listen, all right, we'll figure it out after the fact. So let's go and organize our code base. And what I'm going to do actually is I'm going to sort these into folders. I'm going to create one folder, And we might actually rename some of these classes. Now we'll leave them as they are. But we'll go TileMap G. That's going to be our graphics for the tile map. And we're just going to drop our current code in there. Then I'm going to create a new folder called TileMap D. These are going to be all our... What? That was weird. TileMap D. There we are. I'm actually rendering some video in the background, so I'm hoping it doesn't screw up the the recording too much here. TileMap D. So these are going to be the data for our tile maps. So we're going to go ahead and create a new C# script. And how are we going to name it? I like to sort of fake namespace things, so I might do something like DetailMap, right? For D for data, for example, and why not? And then I might have used TileMap for the others. But what are actual structures that we might want to create? Well, I mean, do we even call it TileMap or map or this or that? Yeah, all right, this will be the structure that holds the entirety of the map data. I think that it will probably have, I'm pretty sure, we'll see. We're going to develop this on the fly, just like everything else. We're going to have also a data type. God damn it. Why? The keyboard, everything's being laggy. Capital T. We're going to have a data type to hold an individual instance of a tile in there as well. You know what? Cancel. Let's not do that. Let's keep it simpler. All right. So we're going to have one class called DetailMap. And this first thing we're going to do is actually take out the Unity engine, and we may not need collections either. And we're going to get rid of mono behavior. This is not going to be a Unity-centric class in any way whatsoever, which also means it doesn't have anything in terms of a start and update. It will have an actual constructor, in which will be called DetailMap, like this, which actually we want to make public. And we might want to have a version that actually asks for a size to make our map, right? So size X and int size Y. Now we can have a default constructor, which if you pass it will just make something reasonable. It'll just call the version. I can't type today. Wow, excellent. We'll start off, we'll make a 20 by 20 map. Okay, there we go. So this is just, if somewhere in our code we call new DTileMap, like this, it's just going to create a 20 by 20 tile map for us, which is, that's exactly what we want. We actually want to store these, so we want our map to remember what size it is. So we're going to go ahead and make those member variables like so. And we are going to store those. We're just going to go this dot that equals the local one, this dot size y equals the local one, like that, and just store that stuff in there. Now, what is our actual tile map data going to be stored as? Now, I mean, we've done some things before. Do I not have that tab open? Oh, maybe because I moved it into a different folder, so it's forgotten some of that. You know, oh, we don't actually store the arrays at any point. That's interesting. We're using a two-dimensional array there, which we may still want to do. And frankly, what the heck, we're going to do that. We're going to have a two-dimensional array, and we're going to store the tile type, whether it is a floor, a wall, or stone. It's just going to be an integer. And we've discussed this before. We may use an enum for this. Ideally, you know, you might want to do enum and then define it that way so that you're not playing with numbers. But we're going to try to keep it bare bones simple. So we're going to use integers to store our tile types. So if ever we look at a tile and we say, oh, it's tile ID number 1, tile ID number 1 will be the floor, right? Because it goes 0, 1, 2, 3. So a tile with ID number 1 represents floor. So, and that'll be walkable, for example. We can do all kinds of those tests in game logic somewhere else down the road, which I don't think we're going to cover in this. But so what we're going to do is we're going to use a two-dimensional array of integers, and this is going to be the actual, we'll call it map data. That's our actual map data. Now we need to instantiate it over here. We're going to say new double array of ints. It should auto-complete-ish, sort of. And it's going to be of size X, size Y, like that. And this should all instantiate everything to zeros, which is unknowns, which is not necessarily what we want, but it's going to be, it's a fine start. So now that we've got this here already, this should create a map filled with zeros, which will all be black tiles. Let's get to the point where we render this on the screen so we can actually see what the heck is going on. So back in our graphical one, let's make some changes to our graphical class. This is mostly going to be a little bit of bookkeeping, and then we will be able to move on with the actual data generation. I mean, I could fill out a bunch more of the data class, but I like to see what's going on to start off with. So, what are we going to do? Well, the build mesh, which is really what gets run on start, and also when we click regenerate. That's the big thing that we care about. Now it's got the size X and size Z in here. Z makes sense in the graphic sense because our sort of distance this way is in Z, even though we're using X and Y in our data, which I apologize if it's confusing, but that's just the way it's going to be, right? And that sort of reminds you of the fact that, yeah, we're working on a graphical set of coordinates here as opposed to something else. So when we build our mesh, what we really want to do is build a new DTileMap of size X, size Z. So right now we're going to do 100 by 50. All right, that's fine. So let's store this somewhere. Are we going to want to keep this around? Yes, we will ultimately. For now, it doesn't matter too terribly much. So we're just going to store it in something like this, right? New map like that. Excellent. Then the number of tiles, number of tries, those all stay the same. It's based on these sizes, which we've already passed to the map. No problems whatsoever. Then it's going to generate some basic mesh data. And this is it. Our mesh is just being created, and that is groovy and fine. I don't remember. Do we set a height at any point? We do set a random height, which I don't want. This is a dungeon. This is going to have a flat height, so we're just going to remove that random height aspect there entirely. So first of all, at this point, our code should still be working, right? So if we hit play, not play. What have I done here? Do I have to make this a two-step process? I guess I can make a two-dimensional array like this in C#, can't I? Or am I thinking a different language? You have to excuse me, I haven't been doing a lot of C# programming around here these days. Let's do this. What am I doing wrong? Come on, C#. C# multi-dimensional. I've been working in way too many other programming languages, mostly Ruby on Rails these days. Well, Ruby, I should say. Right, with the comma, but that's not... Is that the preferred way, really? Am I just going crazy then? It's entirely possible. Entirely probable, perhaps. Did I not just try this? Oh, must have an array size. Yes, of course. So, array X and Y. New int. Why is this not working? Oh, it's this part that's complaining. Okay, good. Excellent. What am I doing wrong? Let's not worry about that. Oh, you're going too fast, getting everything mangled and weird. My apologies, guys, for not being clear. All right. Oh, wow, that's right. All the obsoletes instead. Oh, that's very interesting. Let's go and get rid of these warnings here. So main camera is obsolete. And I used to say that main and main camera are exactly identical. And it's nice that they're actually flagging the obsoleteness of these little code groups. Let's go and clean more of this up. Main, excellent. All right, assigned values never used. That's fine. I'm totally okay with this. Map is assigned but never used. Map data is assigned but never used. All right, all those things are totally fine and groovy. So, yeah, I guess we can get rid of the map portion from build mesh, because the mesh is going to exist, it's going to have the right size, and it's fine. But it's really the texture that we're more interested in this happening. So let's go and create the map in texture instead, because the texture is where we set what graphics are, and we want to use the graphics based on the map here. So we're going to create a texture of exactly the right size based on the resolution. None of that changes. What changes is right here. So we chop up the tiles. We've got our texture atlas, which gets chopped up into individual tiles, and then we're grabbing a tile. Right now we're grabbing a tile at random, but that's not what we want to do at all. We want to grab the ID of the title from our map. We want something like get tile at. This is the thing that we want. We want some sort of get tile at, and at x comma y. I need to spell tile correctly. So now this function does not exist yet, and this has to exist here. We want some sort of public int get tile at x, y. And all we're going to do is return our map data at x, comma, y. So this, I believe, if we were to regenerate, we should get an entirely black map. Assuming, there we go. Assuming anything responds whatsoever. It's not a very fast performing thing, and we know that. And there's lots of different ways to optimize things. For now, what we'll do to speed things up, we're just going to cheat, and we're going to go, tell you what, we'll make a 30 by 30 map. Regenerate that. That should be much faster. Excellent. Now, it is entirely black, which is entirely what we were looking for at this point. And what we could do is we could tweak this. We could, after we generate the map data, let's take the map data at 0.55 and set it to be equal to 2, which should be a wall. So we should have one red wall somewhere in our grid. There it is, right there. So our graphics engine is correctly reading the tiles from our data engine. It's a big part of what we were looking for already done, despite the fact that I went down 2 wrong ends. I really apologize. But what we really want is we want to generate a cool looking grid, right? So I'm going to look at one of the techniques, like I said, very old school, similar to roguelikes, and here's how it's going to do. We're going to plop down some buildings. So it's going to, or some rooms. So what we're going to do is we're going to draw out some rooms. And then what we're going to do is we're going to connect these rooms via hallways. Actually, we could use rectangles to represent that. So we're going to end up with a map that looks kind of like this. And then, we'll get some of them will be sort of staircasey kind of hallways, like that. And then like that, and like that. Something to that effect. We will end up with a map that looks very similar to this. So the first thing we got to talk about is how to generate a room. Well, that's an excellent question. Let's not save this. So what is a room in this context? Obviously, it's a block, and we can define it by saying it's got a top left corner. Do I not have arrows? That is not what I want. I can do it in Photoshop. Anyway, we've got a top left corner, which we can define as having some sort of coordinate there. The smallest it could be is a 0 by 0, right? We could have a 0. Oh, it's hard to draw letters with the mouse. We could have a 0, 0 jammed up in the far top left corner of this map. And one of the things you'll notice actually is it's inverted here, because we went map 0.55 was here, and logically I would normally think of it as up here. We can resolve that in a million different ways if we decide to do so very easily, and we may do that, whether it want to be mirrored or not, because it just comes a factor of how coordinates and map and things work and the way that it grows. We could actually generate, because the problem is when we generate our mesh is it's growing upwards. We actually want it to kind of generate downwards. What the hell? Let's fix that right now. Very easy to do. TileMap. So when we build our mesh, if we threw in a negative on this Z, I think that's all we have to do to get it to grow in the opposite direction. That is true, but it's also upside down. And that is a question of the winding here, which is right in this order. And all we have to do to change that is flip the triangle order around by doing something like this. Let's try that again. So we're going to look at the top. We're going to regenerate. Boom. There we go. That's much more like what I want, except you'll notice these things are also inverted as well, the actual tiles. So, and that is a factor of the UV being upside down. Is a negative here all we need to do? It may be. I'm sort of just eyeballing things right now. Oh, that didn't work at all. Each triangle. Let me think one sec here. Because, I mean, it's working exactly the way it should be, just not the way we want it, which are very different things. Why did it not actually generate a texture? There we go. It should be back to upside down textures at this point, which I may live with instead of like sidetracking myself a whole lot. By size, float z divided by that. New vector 2. This doesn't seem... I'm confused about why this works the way that it works. Tell you what, we'll come back to that. We're going to deal with upside down tiles for now. That's okay. We've got the map direction being a little bit more what we eyeball. We're going to fix the texture thing soon enough. Anyway, it's always an issue because also textures, the way the graphics read in, they're always inverted, and this sort of thing happens all the time when you're working with textures. Moving on. So, all right, we've got, right, so the 0, 0 coordinate of our room. So the topmost room that you could possibly fit would be in here, right in the top left corner. But what we've decided is that our room should always be surrounded by walls. So if we were to make a kind of a more of a grid type thing, right? This represents a room that has been very, very poorly gridded out. Maybe I should have loaded Excel for this, right? You've got to remember that this, like everything on this top row, this row here, this row here, and this row here, we actually want it to be a wall tile as opposed to just openness. So it's not just floor. We want this 0, 0 to actually represent a wall. So if you have something like a 5 by 5 room, what does that mean? Or I suppose I'll go a little smaller. I'll go with a 4 by 4 room. In a 4 by 4 room, if we define it like this, and we're going to call it a 4 by 4 room, and then one in the middle, and then one here. That means the actual flooring space is only going to be this part here. This is going to be the floor. The floor part is going to be 2 by 2, but the entirety of the room is going to be a 4 by 4 area because we're going to count in the walls. We could flip it around, and we could say in a 4 by 4 room, that represents the actual floor space, so we have to make sure to offset things by a little bit to give room for walls and whatever, and I'm not going to do that. I'm going to say that the size of the room includes the walls in there, which is okay. We can do that. Either way is fine, you just have to kind of decide. So I'm going to create a function called makeRoom. All right, so we're going to say void makeRoom. And what is it going to be? Well, it's going to have an x, a y, a width, and a height. And what is it going to do? Well, for now, let's just go ahead and make it all be the floor type, right? So right now, because we're not using enums or anything like that, let's put a little note in here as to what the thing is. 0 equals unknown. 1 equals floor, 2 equals wall, and 3 equals stone. Okay, so make room. We're obviously going to want to make some sort of loop going on here. We are going to want to do something like, actually, instead of calling this x and y, this is going to be called left and top. That's going to be a much better way of working it. Then we can do a for int x equals 0. Well, there's a few different ways. Let's say x equals 0, that's fine. X is less than the width. X plus plus. And that's the other thing I should talk about. No, this is going to be fine. And then for int y equals 0, y is less than height, y plus plus. Let's space this out so that I feel much more comfortable. We're going to do that. And what we're going to do is in our map data, we want to set a tile. Which tile? Well, let's just set x, y for now. And we're going to set it to floor for now. So we're going to do that. Now, obviously, it's not actually x and y. It's going to be left plus x and top plus y to be equal to 1. All right, there's a few other things we want to do, but let's test this out at this point. So instead of setting this line, we're going to say make room, and we're going to set it at the 3, 3 is going to be the top left, or the left top, and we're going to make a 5 by 5 room. All right, let's see if that works. Okay. Far from the most optimal way of doing it, but we'll see if it works. Boom. There we go. We've got a 5 by 5 room. It's indeed, remember, these are 0 indexed, so this is 0, 1, 2, 3. Indeed, on the third one in both directions, we've got a room going on. Well, that's all right. We can do that. Now, let's do a tiny little tweak here. If x is equal to 0, or x is equal to, oops, wow, double equal sign, or x is equal to width minus 1, or y is equal to 0, or y is equal to height minus 1, then we actually want to use the wall, which is number 2. Again, these, using these numeric constants would be way too confusing going forward. You want to figure out some sort of system to keep yourself a little bit better organized, but this is going to work okay for us. So now it should be a room enclosed in a wall. Boom, there it is. In a mall, because we're making M's instead of W's. All right, good. This is working exactly the way that, oops, apparently clicking save caused things to go weird. All right, there we go. And this is exactly the sort of thing we're kind of looking to do here. Good. Now we want more than one room, right? And obviously we want these rooms to be randomly distributed across the screen. How are we going to do that? Well, here's the thing. I actually don't want to just feed a room like this. I want to keep track of where my rooms are. And the reason is, if I can very easily put rooms at random locations. Actually, let's do a little quick loop, okay? For int I equals 0, I is less than, let's make 10 rooms just to be crazy for now, I plus plus, okay? And we're going to make a room at, oh, we don't have the Unity engine, so we can't do the randoms. For simplicity, let's go ahead and do that. You will use the Unity engine's random stuff. There's a system random as well, which, actually, does it work the same way? Not used to doing this anymore. Random dot, yeah, no, it works differently. So, Unity engine. Random dot range. Oh, it just hasn't refreshed. We're going to go from 0 is the minimum. The maximum is what? Well, it's going to be size x minus the size of the room. Right? Because we can't start a room. What's the best way to, like here, and then have it extend past the map. So that's no good. So let's actually randomly generate the size first. So we'll go int size room size x is equal to random dot range. We want rooms between 4 and 8 wide, and same thing for in the y. So rsx, rsy, and so the maximum for the left is going to be size x minus the actual room size in y. And then the same thing, the top is going to be anywhere from 0 to the map size y minus the room size y, like so. I might be off by 1. I'm going too fast to do all the math correctly in my head. Expression denotes a type where. This is the Unity engine though. Yeah, random dot range, that's fine. Oh, random dot range, there we go. Good. Makes room, does that. Okay, so let's play this, and what it should do is create 10 rooms all over the map. Thump! And it does. And it does, and it does. But what should be very clear to you guys right away is there's overlap. Here's a great example of 2 rooms that are overlapping. And actually, depending on what you're trying to do, this might actually be kind of a cool structure where you've got, it's almost a little sliver of a room and a wall, and as long as you could put a door between here, it might be fine. Again, it depends very, very much on what kind of dungeon kind of map you're doing. But if we're doing the strict kind of rogue-like dungeon crawl, or not dungeon crawl, net hack kind of map, this is not the way the rooms generate. They never, ever, ever overlap. So how do we check for overlapness? Well, again, blanks out when I hit save. Huh. All right. And that's just something with a data type not serializing properly. Almost certainly something here. We'll worry about it later. Let's keep moving. So how do we do that? How do we make sure they don't overlap? Well, we have to remember where the rooms are. And to do that, we need a class that holds the room. And this can exist just within the TileMap thing. So we're going to create, not even a public, we're going to create a protected class called DRoom. It's protected because we can only access this within DetailMap itself, or any children that we subclass from here. And so what we're going to do is we're actually going to, these kind of coordinates here, this is what we're going to remember about a room. These 4 things. And they're all going to be, I guess I can't define things that way. That's really quite a shame. They're all going to be public. And public. And yeah, we could do fancy stuff with like protecting this and using a constructor and accessors and all kinds of things. This will be okay. So instead, now when we make a room, and what we're going to do is we're going to keep an array of rooms, right? And let's go ahead and using system.collections.generic, we are going to create a list of drooms called rooms. So when we create our map, we're going to say new list of drooms. We can still create 10 rooms here. We can still randomly generate this stuff. But what we're going to change around is we're going to create a droom, r equals new droom, r dot left is going to be equal to this range here. R dot top is going to be equal to this range here. Oops, missed the parentheses. R dot width, and frankly, you can see this is very close to just using a rectangle class, but we'll go ahead and create our own, is going to be equal to rsx, and r dot height is going to be equal to rxy. So that's not bad. So now we've actually created this room. We will add it to our list of rooms, rooms.add r, and we can still, if we wanted to, we could go ahead and make room. We can just change this to use droom r instead, and then r dot. We're going to be in a pretty similar situation as before. There, I think that's all the little changes we have to do. I don't think I missed anything. Let's go ahead and regenerate. There, exactly the same place as we were before. The difference is, when we create the rooms, we are storing them here. And then what's great about it is, before we add it, we can check to see if our rooms might collide. And we can refuse to add any rooms that might collide. So how do we do that? Well, a couple of different ways, but we want to be able to check for overlap between rooms. So we're going to create a function. It's going to be a Boolean. Does room collides. Okay, so we're going to pass a new room, this room that we're created, r, and what we're going to do is we're going to check it against all other rooms. So for each droom r2 in rooms. So if r dot collides with, well, let's check out what that is in a sec. If our room collides with room 2, then we return true. We can return true immediately. Otherwise, we've checked every room. We're confident that there's no collision. We can return false. What is this collides with? Well, we're going to create it in part of this class. This class is going to have a public function, which is going to return a Boolean, and it's going to say whether it collides with droom other, whether it collides with this other room. And how do we know if 2 rooms collide together? Well, we have the advantage of the fact that these are square rooms, so we can do basic axis, align, bounds, thingy, whatever. Listen, let's make a picture. No, don't save. So we have a room, and we have another room. Now visually we can tell these rooms do not collide. But why do they not collide, whereas this room, these two rooms do collide? Well, the difference is that they have sort of a corner inside one another. And what you can do is you can basically say, for any two rooms, they do not collide if this section here, if the right-hand side is totally to the left of the left-hand side, or if the top is totally below. So and so on and so forth. Let's go through it the other way around. Is the top of this room below the bottom of this room? It's not true. So we can't guarantee that they don't collide. For example, here's an example of where they would collide. So that's not good enough. What about, is it possible that the left-hand side of this room is all the way to the right of the right-hand side of this room? No, that's not true either. Is the bottom of this room all the way above the top of this room? Nope, that's not true. Is the right of this room all the way left of the left of this room? Yes, that's true. Therefore, they do not collide. And that's one way of doing the test. And I think, if I'm thinking through my head correctly, A, I believe that this is the correct method, and B, I think it's relatively simple and fast. I totally accept the fact that I may be misthinking something here, but I'm pretty sure this is the test that we want to do. So basically, if any one of those things are true, it means that somehow, some way, this box is not overlapping with this one. And do keep in mind, at this point, we're including their walls. We're making sure that the walls don't overlap, which may not be correct for your application. You might be okay with a tiny little bit of overlap with the walls, depending on exactly what you're trying to achieve with your map. So, your mileage may vary. You might want to do a slightly different collide test. But in this case, we want them to absolutely positively not overlap, including their walls, just because things, whatever. All right, so if our leftmost side, which is simply left, if our left is all the way to the right of the other room's right wall, so if left is larger than other dot left plus other dot width. Hell, we could simplify it if we wanted to with our class. I could do something like public int right and just have this return left plus width. Is that right, or am I off by one? So let's make a 2x2 room. This is at 0. We've got a width of 2, and the right is actually 1. So no, it is off by 1. There we go. So -1, right? So let's do that. That's a lot better. And why am I getting an error? Oh, because I'm missing my parentheses. There we are. If our left is larger than the other's right, then we can return false immediately. Done. In fact, we can do the non-curly brace version if we wanted to here. Good. While I've got this right going on, let's make one for bottom. So it's top plus height -1. Technically, this would mean then I wouldn't have to use any parentheses, which I like better. What am I doing, you might be asking? I'm just turning this into an accessor instead of an actual function. Basically, it's the same as a function, but it means I don't have to go right parentheses like that. So if our top is greater than the other's bottom, then we know we're beneath the room, so we can also return false, we're not colliding. If our right is less than the other's left, then we're not colliding. And if our bottom is less than the other's top, then we're not colliding. Otherwise, we are colliding. I think that's true. So then what we can do is simply say, if not room collides, then we will add the room to our array. If the room does collide, then we actually just discard it and loop through. So we will end up with less than 10 rooms, assuming there's any collisions. In fact, what you could do is like increase this dramatically. We could try to generate up to 20 rooms. Many of them will collide. The first couple won't. The third one is probably okay. The fourth might collide or not. So we will try to create up to 20 rooms completely at random, discarding any that might be colliding with one another. And let's find out. If I've created some sort of infinite loop, we're going to have a bad day. But I don't think I did. Let's find out together. Boom. That's clearly not doing what I want it to do. Very clearly not doing what I want it to do. We were making the rooms. We were visually making the rooms no matter what, even if we were discarding it. And frankly, we might want to do the make room here. Or, depending on what you're doing, what you could do is after this, you could make your loop for each room. So for each room we actually stuck in the array, then actually make the room for real, right? Either way should work fine. Here's where we add it to the array, and then we can loop through the array and actually add it whether we want it there or not. Either way should be equivalent. Regenerate. There we go. Now we get rooms, and you can see even when they're touching, they can touch and have the double wall, but that's as close as they can get. And again, well, you know, I might not want that. You know, maybe we're okay with the single touch, in which case what we would do is we would define overlapping as, we just throw a -1 in here. Like this would be fine, and +1's over here. Again, I'm going very fast, so it's possible that I've done things backwards, but I'm pretty sure this will allow single wall divisions. Right there, there's a good example, and here. Right? And you can still end up with a double wall. These are rooms that really just happen to drop this way and can still have the double wall. Now, what you could do is another code pass later on. That's another option. Is anywhere you find double walls like this, you might just want to remove some of those extra walls. And that might be a slightly better way for you to do that. But it's really going to depend on the look of the dungeon that you're trying to generate. Very, very different operations. Okay, so the room part is actually the easiest part. The harder part is how the hell we connect everything up. Oh, here's another step I missed. I don't want to have blackness everywhere else. I actually want to have stone everywhere else. So what I'm going to do first is do an initial pass where I first create the map data. I'm going to do a loop for int x equals 0, x is less than size x, x++. What I don't like is there's not a way in C# built in for bulk initialization of an array to a value. Because what I want to do is have every square in the array be initialized to a value of 3. And there's a couple of mem copy-ish things, but not the kind that I would like. Because this loop here is actually rather slow. It'll work, but it's not very well optimized. There we go. So now we have stone everywhere else by default. I mean, the other thing I could do is I could just treat 0 as stone instead of unknown, but then I would have the opposite problem when it came to the player map. So again, this is the system map. This is the real map going on, as opposed to what the player sees. But yeah, so that's all right. So now the harder part are the corridors, because you want to make sure that every room is connected to each other. You want every room to be reachable. I mean, maybe you'll invent secret rooms that aren't supposed to be connectable, in which case you're going to force the player to find a pickaxe and then dig their way over there or something like that. But generally speaking, most rooms, the normal rooms, are going to be connected to one another and reachable in some fashion. So how do we ensure that? It's an excellent question. So, well, actually, this video is already way too long, so I'm going to put a cut in here, and we'll dedicate a second video to room connectivity. See you next time, folks. Bye-bye.